All right, we're looking at target 10.1. Our master learning objective is I can find the trig ratios of special right triangles. So just a quick review of trig ratios, right? It's sine, cosine, and tangent are the main ones we look at. Theta is our angle, right? And we know the hypotenuse of a right triangle, right, across from that right angle. The opposite side is across, right, from the angle, and the adjacent side is next to that angle, okay? And then remembering the definitions of these things, sine is opposite over hypotenuse, which also just simplifies to O over H, right? Cosine is adjacent over hypotenuse, or we say A over H. And tangent is opposite over adjacent, which is O over A. Remember, our best way to remember these is that SOHCAHTOA. Alright, so if we look at an example, we want to find the sine, cosine, and tangent of theta. So here's our angle, right? But we really start with our right angles here. Across from that is our hypotenuse. Across from this given angle is the opposite side. And next to that given angle is the adjacent side. So if I'm finding sine of theta, right, abbreviated just SIN of theta equals O over H, looking at that. My opposite side is 8, and the hypotenuse is 17. All right, and that won't reduce anymore. So 8 over 17 is our sine of theta. Then cosine of theta equals A over H. A is 15. H is 17. And finally, the tangent of theta is O over A. And our opposite again is 8. And our adjacent is 15. Okay? So those are our 3 trig ratios of that angle. Really, more what we're going to be looking at this unit in general is when we have special angles. So our special angles are 30, 60, and 45. These are the angles that occur most frequently in trig. And so we can use these trigonometric values for these angles to find unknown side lengths, and we'll use them for other things as well. So 30 degrees, sine of 30 is 1/2, cosine is square root 3 over 2, and tangent is square root 3 over 3. 45 is square root 2 over 2, and square root 2 over 2 for both sine and cosine. And sine of 60 is square root 3 over 2, and cosine is 1/2. Okay, we are more worried about this sine and cosine. We're not super worried about the tangent with what we're going to be doing in this unit. We're going to look more at these in class tomorrow, but eventually you will have these memorized by the time the test comes along. So just even warning you now that that is something you will need, and we'll do a lot of activities with what these values are. All right, so let's turn to the next page. Like I said, we'll kind of look more at those and why those are the way they are in class tomorrow. If we turn to the next page, the other thing we want to look at today is radians. We've had a slight introduction to radians before. Now we're going to look more at radians in this unit. In this unit, we'll use both degrees and radians pretty equally, so we need to know what both of those are. Okay. So a radian is similar to degrees, where we use it to measure an angle, but 1 radian is the measure of an angle where the length of the intercepted arc is equal to the radius. Okay. So again, one radian is the measure of an angle where the length of the intercepted arc is equal to the radius. So again, this angle, right, is my radian, and it means this arc that it creates here, if I measured that, it's the same distance as this radius of the circle. So those two green pieces are exactly the same distance, and if that happens, then this angle measurement is 1 radian. Okay. As you make the circle bigger, right, this arc gets bigger. And if I made the circle out to here, that would mean this goes out to here, this is still bigger, right? This now matches this. Okay? This angle didn't change size, so it's kind of in a proportion there. Now, because the circumference of a circle is 2 pi r, there are 2 pi radians in a full circle. So degree measure and radian are related by the equation, right? 360 degrees equals 2 pi, right? One full circle, another full circle. We generally use this though. Ooh, that's wrong. I must have copied and pasted it not correctly. 180 degrees equals pi, right? If I divide both of those by 2, right, it just is a little simpler than having a 2 pi in there that's just going to go away anyway, okay? So this is the same as saying half of a circle is equal to half of a circle, right? We can use this relationship to switch between the two. This is the same as saying 12 inches is equal to 1 foot, right? It's a way of switching between the two units. Okay? So if I'm converting from degrees to radians, I want to use this relationship. And usually what we do is if it's in degrees, we multiply by pi over 180, and if it's in radians, we multiply by 180 over pi. And I'll kind of talk about how my brain thinks about which one I want to use. Is it pi over 180 or 180 over pi? So if we look at 135 degrees, I want to get this into radians. I want to get rid of the degree unit, and I want to have a radians unit. That means, right, I want to multiply by pi over 180 degrees. I can put this over 1, because then my degree units cancel out. Okay, so whatever unit it is, you want that to cancel out. And then I'm left with 135 pi over 180, right? And the degrees have already canceled. For when you type this into your calculator, don't type the pi in. Okay, I still want pi in my answer. I want an exact answer. So when I type this in, I'm going to type it just the fraction, 135 over 180 to simplify it. And we get 3 over 4. So that changes to 3 pi over 4. Same thing here, right? You can put this over 1, and then again, pi over 180 degrees, because then this degree, this symbol, and this degree symbol cancel out. I'm left with negative 40 pi over 180. If you simplify that in your calculator, you get 2 pi over 19. Now, if if I don't have a degree symbol, it's in radians. For the most part, radians have a pi symbol in them, but you don't necessarily need it. Okay, it's not necessary. So anytime there's no degrees, it's in radians. Okay, so this is 5 pi over 4. Now, same way of thinking. I knew that was going to happen. Oops. Ignore that. Right, we want to think about what we want to cancel out. Okay. So in this one, we do 180 degrees over pi, because then the radians, the pi radians, cancels out. So I have 5 times 180 over 4. And then we type that in, it's 225. So I should have a degrees. Same thing here, I'm going to multiply by 180 over pi. Again, we want the pi's to cancel out, so we have negative 11 times 180 over 12. And we get negative 165 degrees. I lost my negative, so I'm sure this one got all messed up. It's supposed to be negative 2 pi over 9, so I'm sure someone typed that in their calculator and got confused. Yes, we lost our negative, and I put 19 because I can't read my own handwriting. Okay, so negative 2 pi over 9. And then here we should have 225, and here we should have negative 165. Okay. All right, and that is it. I'll see you guys tomorrow, or on Monday.